Hello guys, welcome back to my channels. So today I'm going to discuss about NMR spectroscopy. So in this video I will cover the NMR spectroscopy and their discovery, rules that predicting the nuclear spins and roles of magnetic fields versus energy levels. And last point I will discuss the chemical shifts. So let's start. So NMR spectroscopy is very important technique that basically used in research and other uh, purpose for knowing the structures characterization. Okay, about the information of peaks and structure, all those things. So let's start. So it's discovered in 1946 by the American physicist F. Bloch from Stanford University and E.M. Purcell from Harvard University. And they have got Nobel Prize in 1952 in physics for first application when NMR spectrum of ethanol was recorded. Now discuss the rules that predicting the nuclear spin. So first rule is if mass numbers and atomic numbers is odd, the nuclear spin I values is half integral. As you can see in these examples, so hydrogen, nitrogen, fluorine, phosphorus, all these elements shows the odd numbers, odd number mass and atomic numbers, and the value I nuclear spin value is half. But in case of this boron, it shows 3 by 2 I value. Second case, if the atomic mass and numbers both are even, then spin is 0. For example, helium, carbon, oxygen shows I value zeros. Okay. Now discuss the last point, that is if the A like mass number is even but Z value is odd like atomic numbers, then spin is integral. For example, 2 hydrogen, 14 nitrogen, I value shows 1, but in case of boron, here the I value is 3. Okay. In earlier case also, the boron value is exception here 3 by 2. All are half, but this one is 3 by 2. In this case also, exception for all these values, the I value is 1. But in case of this boron, the I value is 3. Now discuss some important formula which belong to NMR spectroscopy. Okay. So magnetic dipole moments, this expression where I is angular momentum, Gn is nuclear G factors, and mu and nuclear magneton. So and this expression is nuclear spin angular momentum. If you put this I value in this expression, you will get this. Okay. So now discuss the um, relation, absence and presence of magnetic field, how the energy level will affect. So note point we discuss in absence of external magnetic field, the protons spins have same energy, they are degenerate. Okay, but another case, in presence of magnetic fields, the compound components have different energy. As you can see, this energy level diagrams. This is zero magnetic field. The, the value is m plus 1 half. Okay, degenerate, but in the presence of magnetic field, it splits plus half minus half. The difference of this energy is equal to G and mu and B, that is equal to S nu. And this energy converted to mu form. So mu is equal to frequency is equal to G and mu and B by H. Now note points. Here the Gn can be positive or negative, but mu values must be positive. As also we know, the mu proportional to B, frequency proportional to magnetic fields. So now discuss some points. So nuclei such as even numbers of atomic mass and atomic number like carbon 12, carbon 14 have no spin. I value is 0, so they have no magnetic moment called the non-magnetic nuclei. And these non-magnetic nuclei do not show NMR spectra because their magnetic moment being 0, their energy level does not exist. Okay, and are these organic compounds? The organic compound, those containing hydrogen, carbon, oxygen, only hydrogen nuclei. I values half will show NMR spectrum, not carbon and oxygen. Now discuss the chemical shift. Chemical shift. Actually, the chemist use those compounds that exhibit only a single sharp resonance lines as a reference for the measuring the chemical shift, that is tetramethylsilane TMS. So chemical shift of nuclei A with respect to nuclei B. This expression del equal to chemical shift is equal to B sample minus B reference upon B0 into 10 to the power 10, sorry, 6 ppm part per million. As we discussed last previous slide, the P proportional to mu, hence del is equal to, we replace magnetic field into to this frequency samples minus TMS mu 0 and other terms is same. Now discuss the reasons. What is the reason using for using TMS as a reference? Why people are using this uh, TMS for measuring the sample? So actually this TMS shows 12 equivalent protons which are in same environments, and this TMS gives the single intense peak in its NMR spectrum that is recorded, and this TMS is chemically inert. The presence of methyl group in TMS are highly shielded by their electrons from the external magnetic fields. So here two chemical shift scales, that is delta scales, tau scales, are used in recording NMR signals, that is delta plus tau is equal to 10. Sum of delta and tau is equal to 10. Now discuss the general rules about the spin-spin interaction, calculating the numbers of line in the NMR spectra. So protons of same group do not interact among themselves to cause the observable splitting. For example, methyl group that present and the TMS that do not interact with one another. The multiplicity of the peak of a group of equivalent protons is determined by the neighboring protons. For example, if an equivalent of proton interact or coupled with the proton on an adjacent carbon atoms, the resonance peak is split into n plus 1 peak or signals. So if you see, this is examples NMR spectrum of ethanols. So this peaks, different peaks. This is for hydroxyl group. This is CS2. This is CS3. So if we apply last 2 3 points in this formula, so you will get clear idea. So this will not interact to this, but this four signals comes from this because methyl group have 3 protons. So n plus 1 means 4. 3 plus 1 you will get 4 signals. Similarly, from this CS2 group you will get 3 signals because here present 2 protons. Okay. So I hope you understand the basic things about the NMR spectroscopy. So if you found this video interesting, please do like and comment, and don't forget to subscribe this channel. Thank you for watching.